In today's lesson, you will learn about the periodic table. You will learn about some major groups of the period and features of the periodic table. You will describe valence electrons and learn how to determine the number of valence electrons from the periodic table, as well as use the periodic table to determine the charge of some ions. To start off with, if you would please go into Schoology, go into our course, go into our current week, and find the Introduction to the Periodic Table notes in there, and go ahead and download that PDF into Schoology into Notability. So here's our story. Once upon a time, philosophers and scientists have always wanted to know how to organize the known elements. What they knew as elements increased through time. As we got later and later in history, more and more elements were possible. How many elements? Well, if we look just 300 years ago, there were about 14 known elements. Through the 1800s, the number of elements known grew dramatically. And then in the last 100 years or so, we've added about another third periodic table elements. Okay, as of 2010, we know of 118 elements, and that's what we see on our periodic tables that we have today. Let's go ahead and hear about some of our periodic table elements.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Yes. All right, and so that is all of our elements in the periodic table. There are a few more down here in the bottom row that you'll see on yours that weren't around when this video was produced. But again, most of the elements here toward the end are elements that are only lab produced by smashing atoms together, and they only exist for short periods of time. So again, the bulk of the periodic table and the elements that we have on there are the elements that we know of today. And the periodic table is our way of organizing that. So today we're going to go ahead and we are going to take a little tour of the periodic table by coloring the periodic table in a few different ways so we can understand some basic features of it. In order to do this, you are going to need some different colors and we'll be able to color in your periodic table. So hopefully you have a way at home that you can scrounge together some colored pencils or crayons or something along those lines, or maybe just 4 different colored pens, something like that. But see if you can get some different colors together and then come on back to the video. All right. So let's start off by looking at the modern periodic table and how we go about organizing it. Okay, so the periodic table is organized by increasing atomic number. These happen as we go across the rows. Okay, those rows are also called periods. So as we go across the periodic table, the atomic number increases and we call what goes across there the periods. Okay? So as we go across the periods, the atomic numbers get bigger and bigger and bigger as we go down the periodic table. Okay? Similar properties is what organizes our columns. So those we refer to as groups. So coming down the side here, these are our groups. Okay? Those groups have similar elements in them have similar properties to one another. If you could please go ahead on your very first periodic table that's in your notes, table 1. The next way we look at the periodic table is by looking at some major regions on the periodic table. The first major region is known as metals. Metals are elements that are usually solid at room temperature. They're usually shiny. They tend to conduct heat and electricity pretty well. And many of them tend to be somewhat bendable. Some of them are stiffer than others, but some things are sometimes very bendable. You can think about this if you think about a wire, right? A wire is a piece of metal, and that's usually fairly bendable. Second major group of elements are the nonmetals. Okay? Nonmetals can be solid, liquids, or gases at room temperature. They come in a variety of appearances. They can be solids, liquids, and gases. They can be different colors, etc. They tend to not conduct heat or electricity very well, and they tend to be very brittle. Okay? The third group is sort of an in-between group. Okay? These are the metalloids. They are typically solid at room temperature. They can be shiny, but sometimes they are dull. And they also partially conduct electricity. On our periodic table, the metals, the nonmetals, and the metalloids fall into distinct regions. So if you could go ahead and label table 2 and color it with metals, nonmetals, and metalloids. Okay. We have, so here are our metals, all the things in gray. Our nonmetals are all the things in gold over here, plus hydrogen. And then our metalloids are these 7 elements right here, sort of in between them. Go ahead and pause the video, get those colored out. Okay. One key feature on our periodic table is the stair-step line. Okay. The stair-step line divides the metals from the nonmetals in general. All of the metalloids sit right on the stair-step line somewhere. Okay, so if you could go ahead and add the stair-step line to table number 2, this black set of stairs, and label it. Go ahead and label it the stair-step line. We can break the periodic table down even into more specific groups, grouping elements together more specifically than metals, metalloids, and nonmetals. And in these groups, we'll find very special elements and special groups of elements along the way. So we're going to go ahead and we're going to start with the most basic element that we've got, and that's hydrogen. Okay, hydrogens have 1 proton in the nucleus, 1 electron on the outside. Simplest element that we have in nature. It is also the most common element we have in the universe, and when we see it at room temperature, it comes as a clear gas, meaning it has pretty low density. It tends to react very vigorously with other elements. It tends to also be extremely flammable. Okay, one of the most famous historical stories about hydrogen is about a blimp, a Zeppelin called the Hindenburg, that in 1936 was coming into land in New Jersey when a gigantic disaster happened. And we'll watch that video of that disaster in just a second. Modern blimps are filled with helium. Helium does not burn, but hydrogen does. And so here's what happened in 1936 to the Hindenburg, because it was filled with hydrogen.
It's practically standing still now. They've dropped ropes out of 400 or 500 feet into the sky. It's a terrific crash, ladies and gentlemen. The smoke and the flames now, and the flame is crashing to the ground, not quite to the mooring mast. All the humanity and all the passengers speeding around. I told you. It's practically standing still now. They've dropped ropes out of the nose of the ship, and it's been taken a hold out down on the field by a number of men. motors of the ship are just holding it just enough to keep it. It works in the plane. Wait, get it started. It's crashing terrible. Oh my. It's practically standing still now. They've dropped ropes out of the nose. Get out of the way, please. It's bursting into flames and it's falling on the morning beds. All the folks believe that this is terrible. This is one of the worst catastrophes in the world.
The next group of special elements we want to talk about are called the alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They tend to have normal metal properties. They're shiny, they're bendable, things like that. They conduct electricity and heat. But they also tend to be extremely soft. You can actually cut them, as we'll see in just a second. And they always react with other elements. They're so reactive that you have to keep them in a vacuum or away from oxygen even, to keep them from reacting as they are. Okay, so they do react with water and air. And the bottom one in them element in them is francium. Now this picture that they've got on here is not actually francium. It is a rock that has some francium in it. They estimate that if you took all of the francium that currently exists on planet Earth, you could fit it all into your palm of your hand. But that francium is dispersed in rocks all over the place, and so it's an extremely rare element along the way. If you would go ahead, please, and take the alkali metals, here's where you find them on the periodic table, go ahead and color them in and label them.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.
Straight out. I should probably throw it that way, huh?
Yeah, throw it that way. Good frisbee. Ready?
All right, ready?
Everybody ready? 3,
2, 1.
Oh, that's a little...
Oh! Oh! Oh!
Let's go ahead and watch a couple quick videos about alkali metals.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster. But the black...
The next group of elements we want to talk about are the alkaline earth metals: magnesium, beryllium, calcium, strontium, barium, and radium. They also are metals, so they have normal metal properties. And they tend to make bases when you combine them with water, which is why we call them the alkaline earth metals, because alkaline is a word that oftentimes means something is base or basic. They always react with other elements, and they happen to be important in many life processes. Go ahead and color and label the alkaline earth metals on your periodic table. Number 3. The next group of metals that we have are called the transition metals. Okay, transition metals are all of these metals that are sort of in the middle of the periodic table and down here toward the bottom. They have normal metal properties, however, they're less reactive than the alkali metals or the alkaline earth metals. They also tend to be more colored metals. They aren't always just gray, so you tend to get some silvers and some coppers and some golds and even a little bit of purple hues in there. Okay, they are important in making metal products because they are not reactive. So iron, gold, silver, copper, nickel, all of those are transition metals. Go ahead and color and label those on your periodic table. The next group of special elements we want to talk about is halogens. Halogen means salt maker. And in this case, salt isn't just like the stuff that we eat, put on our food. Salts are any compound that's made of metal and nonmetal combined. Okay, so halogens tend to be nonmetals. They have nonmetal properties. Here are 3 of them. These 2 are gases. Chlorine and bromine are gases at room temperature. Iodine is a solid at room temperature. And they always react with other elements. Okay, they are also, again, highly reactive. So they're responsible for making lots and lots of different compounds. Okay. We can go ahead and color and label those, fluorine, chlorine, bromine, iodine, and astatine, on our periodic table number 3 and label them halogens. The last group of special elements we want you to get are the noble gases: helium, neon, argon, krypton, and xenon. They are also nonmetals, so they have nonmetal properties, and they are so unreactive they almost never react with anything. They're used in places where you don't want reactions, like in a neon light tube, or like in fluorescent lighting above us in our classroom. Okay? Noble gases are extremely unreactive. Go ahead and color and label those on table 3.